Hello, welcome to 4.1, Introduction to Polynomial Equations and Graphs. Okay, zeros of polynomials and solutions of polynomial equations. The first thing we should talk about is zeros of polynomials. The number k may be a complex number by the way, is said to be a zero of a polynomial. A function, there's a typo that persists in this. This should be to the n power. A sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 a sub 1 x plus a sub 0 if f of k is 0. If you plug k into this function, you get a 0. It's a 0 of the polynomial. This is also expressed by saying that k is a root. So saying it's a 0 is the same thing as saying it's a root or solution. So being a root, being a solution, and being a 0 of a polynomial are all the same thing. I should say solution of the equation f of x equals 0. So polynomial equations. A polynomial equation, one variable is an equation that can be written in the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot dot dot. That means all the terms in between plus a1x plus a sub 0 equals 0. Where a sub n minus 1, and a all the way through to a1, a0 are constants, and n is a positive integer. Assuming that the leading coefficient is not 0, then a sub n is your leading coefficient. It's degree n. So if it's a3 that's there, it's degree 3. That's the highest. So leading coefficient a sub 0, it should be, is a constant coefficient. Now let's look at example 1 here. It says verify that the given values of x solve the corresponding polynomial equations. So in this first case, we have x squared minus 4x equals negative 13, and x equals 2 minus 3i. Now recall that a plus b squared is a squared plus 2ab plus b squared, and a minus b squared is a squared minus 2ab plus b squared. We have a minus here with that squared. That's going to be 2 minus 3i squared minus 4 times 2 minus 3i equals negative 13. That's going to be 4 minus 2 times 3i plus 3i squared minus 8 minus 12i equals 13. This is 4 minus 12i plus 9i squared minus 8 minus 12i equals 13. So we have 4 minus 12i plus, I should say minus, because I squared is negative 1. Negative 9 minus 8 minus 12i equals 13. Okay, so negative 12i, oh, one was a plus 12i. Oh, there's double negative. That should be a plus there. So that one's going to cancel. 4 minus 9 is negative 5. Minus 8 is negative 13 equals negative 13. So that worked. So we'd say x equals 2 minus 3i is a 0. Or a root, or solves the equation. Okay, let's try x equals 5 halves. We have 9 times 5 halves squared minus 4 times 5 halves equals 2 times 5 halves cubed plus 15. This is 9 times 25 fourths minus, well, 4 times 5 halves is just going to be 10, right? Equals 2 times 125 over 8 plus 15. So 9 times 25, that's going to be 225 over 4 minus 40 over 4 equals, and this reduces to become 125 over 4 plus, that would be 60 over 4, wouldn't it? 225 minus 40 would be 185 over 4. Is that's going to be equal to 125 plus 60 is also 185 over 4. So it works out. Let's go on to the last one. Okay, it says here x to the sixth minus x to the fifth plus 7x to the fourth plus x cubed minus 9x equals negative 1. We're going to put negative 1 in here. So negative 1 to the sixth minus negative 1 to the fifth plus 7 times negative 1 to the fourth plus negative 1 cubed minus 9 times negative 1 is negative 1. So it's 1 minus negative 1 plus 7 times 1 minus 1 plus 9 equals negative 1. So 1 minus negative 1, that's 2. 2 plus 7 is 9. Okay, so we get 9, and then minus, so we have 9 minus 1 is 8. 8 plus 9 is 17 equals negative 1. Well, that's not the case. This is not true. So x equals negative 1 is not a solution or root. Let's go on the next page. Graphing factored polynomials. So consider the polynomial a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 a sub plus a sub 1 x plus a sub 0 with real coefficients. We want to be able to sketch the graph of this function, paying particular attention to the behavior of f as x goes to negative infinity and x goes to positive infinity. I talked about this back in chapter 3. The y-intercept of f, paying attention to the y-intercept of f, and the x-intercepts of f if there are any. We can determine the behavior of f as x goes to negative infinity and positive infinity, called end behavior, in the following way. As x gets very large or very small, the odd functions tend to behave similarly. Likewise, the even functions tend to behave similarly as x assumes these extreme values, going way big and way small. The following chart illustrates what happens to the functions when x is going towards the negative infinity or positive infinity. So here we have the leading coefficient being positive and n is odd. As n is odd, as x gets big, it's going up, 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 up. As n is small, or if n is positive, sorry, if a is positive and n is odd, as x gets really small, goes negative infinity, this gets really small. Keeping with a positive theme for an even function, it's going to be going up on both ends, where the odd function goes down on one of them. Now, in the second case, you have a sub n being negative, your leading coefficient's negative. That means as x gets small, this is going to climb, 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 climb to infinity. As x gets very big, it's going to go down, 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 down. And for an even function, when your leading coefficient's negative, it's going to go down on both ends. As x gets really big, it's going to go to negative infinity. As x gets really small, it's going to go to negative infinity. So what this chart does not address is when the values of x are relatively small, like around 0, like maybe negative 10 to 10. It might be doing something different, maybe going up and down, who knows. For the smaller values of x, it's best to find the zeros through factoring the polynomials. For each of the following polynomials, determine the degree and the leading coefficient and describe the behavior as the graph goes to positive or negative infinity. So here, this is degree 7, and this is an odd function. Now, leading coefficient is 4. Which is positive. So, as x goes to infinity, f of x will be going to infinity as well. As x goes to negative infinity, f of x will go to negative infinity because it's an odd function. So it's going to go up as you go to the right, going to go down as you go to the far left. And you're kind of doing that and this. Now the next case, we have g of x is negative 2 times times x plus 4 times x minus 4 times x squared. And we can multiply this out if it helps. This would be negative 2 times x squared minus 16 times x squared, which becomes negative 2x to the fourth plus 32x squared. So our degree here is 4. That makes it even. Our leading coefficient is negative 2. Being a negative leading coefficient, we have something like this. It's going to be going down in both directions. As x goes to infinity, it's going to go to negative infinity. As x goes to negative infinity, it's going to go to negative infinity. So as x goes to infinity, g of x goes to negative infinity. As x goes to negative infinity, g of x will also go to negative infinity. Okay, I'm going to go on to the next one. For each of the following polynomial functions, describe the behavior of its graph as x goes to positive, negative infinity, and identify the x and y-intercepts. Use this information to then sketch the graph of each polynomial. Okay. Well, we can multiply this out, and our g of x, we're looking at multiplying right here. It's going to be 3x plus 6 minus x squared minus 2x times x plus 4. So that's going to be, what? Negative x squared plus x plus 6 times x plus 4. So if we keep going with this, negative x cubed minus 4x squared plus x squared plus 4x plus 6x plus 24. So negative x cubed minus 3x squared plus 10x plus 24. Now our degree here is 3, so it's odd. Not an odd function, but it's odd degree. Our leading coefficient is negative 1. And that's negative. So we can use the information up here to find our intercepts. So we have x equals 3, x equals negative 2, and x equals negative 4. And we know that being negative, leading coefficient, that means as x goes to infinity, g of x will go to negative infinity. So it's going to be going down there. As x goes to negative infinity, g of x will go to infinity. It's going to go up there. Let's see, can we find a y-intercept? What is g of 0 going to be? Just go to here, g of 0 is going to be 24. Just putting 0 in all those x's. So if I scale this, 4, 8, 12, 16, 20, 24. We can plot this out. We know it has a y-intercept of 24. We have the x-intercept. It's going to be going down that way. Going up to 24, coming back down, and going back up. And there is our graph. As a matter of fact, it could be actually coming up even steeper and coming down to that 24. But that's a rough idea of the graph. The point is, as x gets big, this is going to go to negative infinity. As x gets small, it goes to positive infinity. Now for the next one, h of x equals negative x to the fifth plus 3x to the fourth plus 4x cubed minus 12x squared. Okay, so in this case, our degree is 5, which is odd, and our leading coefficient is negative 1 again. That's negative. So if we factor this, h of x is going to be, can pull on an x squared, I'll pull on a negative x squared times x cubed minus 3x squared minus 4x plus 12. I'll do some factoring by grouping and see if that works. Now watch when I do this. Don't forget how to do factoring by grouping. When I group that, this sign in here changes to a negative. So our h of x is negative x squared times x times x squared minus 3. Oops, wrong color. Minus 4 times x minus 3. Excuse me. There should be a squared there. We'll pull on an x squared. So just x minus 3, 4 times x minus 3. Okay. So h of x is that negative x squared out front. We have a repeated factor of x minus 3. And if that x minus 3 is gone, we have an x squared minus 4 left. So this means h of x is going to be negative x squared times x minus 3 times x minus 2 times x plus 2. So our zeros here. Well, where's negative x squared equal to 0? That's where x equals 0. Where's x minus 3 equal to 0? That's where x equals 3. X minus 2 equals 0, where x equals 2. X plus 2 equals 0, where x equals negative 2. So we have negative 2, 2, 3, and 0. And we know y-intercept. So if we go back to the original, h of 0, if I put 0 in all these, I just get a 0. Okay. And that makes sense because there is our y-intercept. Okay, with that in mind, we can go ahead and graph this. It's odd with a negative leading coefficient, so that means this one's going to go up. This comes down. Now, because x equals 0 as a double root, it's going to come here, touch, come back down, go up, come down again. When you have a double root, and we had x squared as a root, we had a double root, that means it touches that one and goes back the direction from which it came. And there's our graph. Not like a double rainbow, though. It's just a double root. Okay, moving on to our last page from this section. So feel free to pause that. Solving polynomial inequalities. Every polynomial inequality can be written in the form f of x is less than 0, f of x is less than or equal to 0, f of x is greater than 0, or f of x is greater than or equal to 0. So you're going to graph the polynomial f. So just graph f. And look for the places in the graph in which the inequality is satisfied. So is it bigger than 0 if it's above the x-axis? Less than 0, it's below the x-axis. Greater than or equal to, where it's equal to 0 or above the x-axis. Less than or equal to 0, equal to 0 or below the x-axis. Okay. So solve the following polynomial inequalities. I bring everything to one side here. Call this x squared minus x minus 6 is greater than 0. So we're going to graph f of x equals x squared minus x minus 6. So f of x equals x minus 3 times x plus 2. I'm going to graph that. X minus 3 equals 0, x equals 3, x plus 2 equals 0, x equals negative 2. So we have negative 3, we have 2. This parabola is going to open up. It's going to look something like this. So this is, we're asking where is this going to be positive? Well, this is positive on this interval and here. So from negative infinity to negative 3, and then from 2 to infinity. Now there's another way to do the same problem. The table format. So without graphing this, we have our factors, and they are x minus 3, x plus 2. And we have critical values at, I think I need one more line, 3 and, no, I got those backwards, negative 2 and 3. I got that totally backwards. It's x equals 3, x equals negative 2. I didn't graph that right. So it's 2 and 3 there. There we go. So it's negative infinity to negative 2 and then 3 to infinity. Now, another way to do it with the table format, you know the zeros. So pick test value, something smaller than negative 2. I'll just go negative 3. Pick something between negative 2 and 3. And then I'll pick 0. Pick something bigger than 3. I'll go with 4. Plug it in. Negative 3 minus 3 is negative 6. That's a negative. Negative 3 plus 2 is a negative 1. That's negative. A negative times negative is a positive. Put in 0. 0 minus 3 is negative. 0 plus 2 is positive. A negative times a positive is a negative. Put in 4. 4 minus 3 is positive. 4 plus 2 is positive. A positive times a positive is a positive. So if we're looking for places this is greater than 0, where's it greater than 0? Well, this interval means from negative infinity to negative 2, then from 3, the test value, to infinity. And notice I have the open parentheses there at negative 2 and 3. Not inclusive of those. Okay, let's go on to part B here. We have x cubed plus 3x squared plus 2x is less than 0. So here we're looking for values that are below the x-axis. And if we treated this as f of x equals x cubed plus 3x squared plus 2x, we'd have f of x equals x times x squared plus 3x plus 2. Or f of x equals x times x plus 2 times x plus 1. So x equals 0, x equals negative 2, x equals negative 1. Those are our zeros. Leading coefficient is positive, and it's degree 3. So it's going to be odd. So that means it's going to be going up like that. It'll come down and go up, come down like that. If we're looking for places that's negative, where is this going to be negative? Where is it below the x-axis? In this region, in this region. So it's solved from negative infinity up to negative 2, and then from 1 to 0. Now we can do this in the table as well. have negative 2, negative 1, and 0 as our zeros. Our factors are x, x plus 2, and x plus 1. So something smaller than negative 2, I'll go with negative 3. Between negative 2 and negative 1, I'll go with negative 1.5. Between negative 1 and 0, I'll go 0.5, and bigger than 0, I'll say 1. You put negative 3 in here, that's negative. Put negative 3 in here, that's negative. Put negative 3 in here, it's negative. A negative times a negative times a negative is a negative. Put negative 1.5 in here, that's still negative. Put negative 1.5 in here, it becomes positive. Putting negative 1.5 in here, it's negative. That's a positive result. Putting 0.5 in there, you're going to have positive. No, it should be negative 0.5, I'm sorry. It'll be negative there, positive, and negative 0.5 in here, you're going to get positive. So negative times a positive is a negative. And putting 1 in all of them, you're going to get positives. And suffice it to say, once it goes positive, being linear, it's going to stay positive. So we're talking this region and that region corresponds negative infinity up to negative 2. And then this one from negative 1 to 0. Now luckily our last one's already factored out for us. So we could say f of x equals x minus 1 times x plus 2 times 3 minus x. In this case we're looking for it being less than or equal to 0. So we're going to end up when we have those constants, not for infinity or negative infinity, but we'll have closed off, squared off brackets there. So we know right off we have x minus 1 is 0, x equals 1, x plus 2 is 0, x equals negative 2, 3 minus x is 0, that 3 equals x. So we have negative 2, positive 1, and 3. Now if you were to multiply this all the way out, you're going to have a degree 3 with a negative leading coefficient. Why negative? Well, x times x is x squared times negative x is negative x cubed. So that means it's going to be going down here, it's going to be going up there. As far as f of 0 goes, it's going to be negative 1 times 2 times 3, and that's negative 6. Come down here, let's call that negative 6. Here, go up, and come back down again. So the question is, where is it going to be less than or equal to 0? On that region from negative 2 to 1, and then from 3 to infinity. So negative 2 to 1, from 3 to infinity. And I'm going to leave it like that. And that'll do it for 4.1. That was kind of a longer section. Okay, send me your questions. Thank you.